Hey there and welcome to the third stage of my retro 24-hour clock. There's not too much theory in this one, it's more about the build. The only little bit of theory we've got to contend with is the connections for the 7-segment display and how it's connected to the decoder. This 7-segment display is a common anode one, which means that either pins 3 or 8 are connected to power and the other pins are connected, as you can see, A to A, B to B, C to C, D to D, E to E. We also need to connect ground and power, and pins 3, 4 and 5 will also need to be connected to power if your decoder is to function correctly. And finally A0, which corresponds to A, A1B, A2C and A3D all need to connect to your counter. Of course, don't forget when connecting A to A and B to B to use a current limiting resistor, otherwise your 7-segment display will blow up. You'll go through a series of stages. Here I'm checking the power continuity for the 7-segment displays, and you can also do a functional test of each 7-segment display by connecting the power and briefly touching each connection to ground, as you can see. The next stage is to connect power to the decoders, and after that ground to the decoders, and don't forget of course to connect pins 3, 4 and 5 to power as well. I thoroughly recommend that if you're going to build on breadboard in this fashion, you colour code your wires. It will save you an awful lot of hunting around for any mistakes you're going to make, because invariably you will make a mistake with this type of circuit. Colour coding just saves you an awful lot of hassle. Make sure you check your power and ground continuity. I would recommend that you test each stage as you go along. That way it's much easier to trace any faults in the circuit. If you do go ahead and build this circuit, I hope you had a lot of fun doing it, and I hope it worked just as well as mine did. Goodbye.